Welcome back to UAP Rant. We're into episode 23 now, so a few more episodes to go before we end the series. We're well into discussing the phenomenon in terms of UAP or UFOs now, and looking more at the tools for collection of data and the application of science and the scientific method. Following on from through the whole series, we were trying to redefine how we come to understand UAP by referring to time as scalar and looking more at how to develop the science around four-dimensional space in terms of observation and data collection, mainly because I've been building on referring to Maxwell's original quaternion notation, where he noted the fourth dimension of time as scalar and how that was modified into vector calculus by Heaviside, and then how special relativity was determined by Einstein in terms of space-time, and that we've missed a key aspect of science here, which I've connected to field repulsion science through understanding the fourth dimension as scalar when we refer to time. So it has no direction or no vector, and past, present and future all exist simultaneously. And in the previous couple of episodes we've been talking about how we apply that thinking to the five observables of UAP, and now we're talking about the science of that, how we collect the data and redefine our scientific understanding. Otherwise, we're going to keep going round and round and round in circles looking at the five observables using known science, which ultimately is not going to get us anywhere nearer or further in developing our understanding of how UAP or UFOs work, and how we interact with and determine meaning behind the five observables, and develop technology which may or may not already be held by the private sector. But in terms of public science, it's a paradigm shift in thinking, and we have to go back in time and look at what we've missed or what's been taken offline and what's been coveted in terms of publicly accessible science, because it's not going to work applying that to if we keep applying that to UAP. All I see is us going round and round and round in circles. Another Project Blue Book, debunking a lot, which is fine. A certain percentage are left unexplained, and then we apply the same old science and do the same old thing, and we get nowhere. Right? So what's the science that we need to look at in terms of collecting data this episode and next episode? I'll just start with tools for collecting and identifying four-dimensional phenomena. So I'm going to refer to it as four-dimensional phenomena. So we need advanced sensor arrays to start with, and they've got to be capable of detecting and interpreting phenomena in space-time. So we need time-resolved imaging, so cameras that can capture light events at very high frame speeds, which some are already doing and deploying sensor arrays to observe transits or distortions in space-time. So our work on orbs and rods was at 30 frames per second, and we compensated for that by having something that was repeatable and measurable and done over and over and over again in the field exactly the same way, so that we could come up with some sort of information and determination. But if you can't do that in applying the scientific method, you need some very powerful high resolution, high frame speed tools, of course. LIDAR and radar for your 3D spatial mapping, which would augment temporal resolution in terms of high frame camera speeds to track objects in motion, study how they interact with our physical dimension or space-time, all right, popping in and out of scalar, the fourth dimension, and interacting with space-time. Quantum sensors is a thing we need to look at. So sensitive devices sensitive to minute variations in gravity and electromagnetic fields, because in the field with orbs and rods, we looked at the changes in electric and magnetic field strength, energy coupling and energy cascades, which I think is key when we look at how space-time interactions with the fourth dimension are occurring in terms of manifestation of these phenomena. So an application like that would be tracking UAP by deploying these sensor networks to correlate spatial and temporal anomalies to detect these objects transitioning through higher dimensional states and popping in and out of our dimension. So we could look at things like AI, enhanced pattern recognition when we analyze collected data, and using machine learning algorithms. So your traditional multi-dimensional scaling software in terms of rotated factor analysis, principal components analysis, logistic regression, and other AI learning tools. And through that we can look at patterns in anomalous movements, so your instantaneous acceleration, jumps between points in space and time, temporal distortions from high-speed footage, correlations between light spectra and energy signatures, which is a key one that we also looked at with orbs and rods. And an application of that might be identifying and categorizing UAP behavior and distinguishing between atmospheric phenomena that's natural, the man-made objects, and potential interdimensional activity. Now I know Tedesco are developing and are using some pretty advanced sensor systems and arrays in that regard, and they've got some papers out which are really good and pointing the way for the way that we should head with all this. I'll leave it at that for now. I will go through the rest of the science behind this and how we redefine our thinking in terms of applying the scientific method for four-dimensional phenomena for the next episode. And then in episode 25 I just want to wrap it all up and bring the podcast series to an end. So we'll talk soon.